Okay, so going viral would be the title of my career path. And if we check what are the key requirements for a content to go viral in internet, we can find that it has to be something amazing or breathtaking, also fun, imaginative, better if provocative or controversial, or either helpful and unique. It must have an emotional connection, and very importantly, it should be distributed using the right channels and the right influencers. So I was starting looking for those ingredients, and I started my PhD in an amazing wall of animal viruses, and I joined the lab of Luis and Juanes in the National Center of Biotechnology in Madrid. And I started studying the coronavirus replication mechanism, both sequences required and cellular proteins and viral proteins involved. So by using reverse genetic system and the transmissible gastroenteritis coronavirus as a model, we could find that the viral nucleoprotein had an essential role in coronavirus replication. We also studied the cis-actin signals that they were required for coronavirus replication. We were located at both ends of the genome. And it was 2002 when we were engineering coronavirus vectors when something breathtaking just happened. This was the SARS outbreak that put coronaviruses in the forefront of world's attention. So in a joint effort in the lab, we assembled together a SARS coronavirus infectious clone and a replicon, and this opened up a new line of research in the lab. So I went back to the coronavirus replication mechanism because I wanted to identify which cellular proteins were interacting with the replication signals located at the ends of the genome. And the right channel to do that was a collaboration with the lab of Alexander Akulichev at Oxford University. So very quickly in his lab, I could set up the assay and identify the binding proteins by mass spectrometry. And then once back in Madrid, we spent some time studying the role of those proteins on coronavirus replication. And then it was time for me to go for a postdoc, and with this decision-making process, which is highlighted here. So basically, I wanted to change a little bit the field. I was fascinated by the non-coding mammalian genome. I also wanted to go through the right channels to have the support of a strong lab and a strong institution. But not only that, I wanted also a place to enjoy. And because of personal reasons, I want a convenient connection to Madrid in order to keep in contact with my significant other. So this place happened to be Freiburg in Germany, where I joined the lab of Thomas Janowijn at the Max Planck Institute of Immunobiology and Epigenetics. So his lab studied very basic questions about non-coding RNAs and mammalian heterochromatin, which is especially challenging to study because it's made out of repeats. So as you can imagine, going into this mechanism is not easy. So we together could draw an epigenetic map for the heterochromatin, and we also decipher what is the silencing mechanism for endogenous retroviruses and active line elements, specifically in ES cells. So the Rna project was even more challenging and more fun because we were studying the non-coding RNAs coming out of heterochromatin, and at the end we find out that they are forming RNA-DNA hybrids and that they are also forming nucleosomes, and this is one of the hallmarks of mammalian heterochromatin. And this project was not only fun because of the mechanism definition itself, but also this creativity required a nice group of people, which is depicted by this cocktail of flags, and it was very nice to work together with. So I could, perhaps thanks to the long winters in Germany, I could also use my creativity outside of the lab, and I did my first photography and also painting exhibitions. And then after 5 years of postdoc, it was also time for me to go for my next step, and again, another decision-making process. And at that time, my requirements were different. I wanted to move to an industry setup, so still stay in research, but something more applied. so maybe something like applied research. Of course, to go for a challenging project in a good institution, but also compatible with starting a family. So I was looking to go back to Madrid, but because of the financial crisis, there were very few open positions in science by that time. So probably the more difficult decision I have taken was just to quit and come back without having anything secure. So for the transition, I decided to join a business school program. So I studied in IE Business School in Madrid, like an executive program for researchers. And this worked quite well for me. It was a nice transition, and I learned a lot of different things, and it was also fun to do, and a good transition to industry. And finally, I found the right place for my next career step, and this was Ingenasa. Ingenasa is a strong biotechnology company with more than 35 years in the market of veterinary diagnostics and also food quality. So what makes the company so unique is the strong research focus. Actually, the R&D department accounts for half of the company. So as an example, these are the projects of external funding that we have right now ongoing. And these are the core technologies that we use and we offer service for. And all this translates into a broad catalog of more than 100 references. So my role within the company was to start a new research line for novel diagnostic tools for aquaculture. And now I have 2 lines of research, one focusing on fish viruses, and the other one is a participation in a European project that addresses fish parasites. So just an example, and I have a poster outside with more details. We have obtained other virus-like particles, and they are nice tools which we can develop specific antibodies, diagnostic assays for sea bass, and they are also promising vaccine candidates. Yeah, I finished. So those are the ingredients that they work for me. And this will be also my advice to starting scientists. Try to find something amazing, a nice project that motivates you, in a nice working environment. Don't be afraid of changes. Keep and take care of your emotional connections, and always use the right channels and the right institutions to work for. Thank you.
We have time for 2 minutes of questions.
We talked a lot about the differences between industry and academia, and given you experienced it clearly, could you comment on the differences or similarities of research within the 2 settings?
Yeah. So in terms of science, when you work in academia, and especially when you work on fundamental, very basic questions, you are a bit more free, and you can be more open in the way that you conduct your research. As far as something is unpublished and new and relevant, you can maybe open a bit more the possibilities if your funding allows for. But if you go to industry, you are more, at least, prototype driven. So you want to study something because ultimately it could be some prototype that could be applied in industry, in case of veterinary diagnostics, for instance. So it's a bit more narrow, the focus. In terms of pressure, maybe in academia you have more publishing pressure. Meanwhile, in industry you are more market pressure or competitors' pressure. And in terms of daily work, well, as I have said, in my company, the R&D department works very much as a research department, in terms that if we have so many European projects, you have to do the project reporting and accomplish the goals, the same as in academia. But we have a rich environment in the sense that we work in many different projects in the same setting. But on the other hand, we don't have for instance, the regular seminars that you will have in a research institute, in which maybe weekly you have nice speakers coming up and giving seminars. So you have to to be updated and to look for the scientific outputs a bit outside. It could be, but probably it's not very typical industry I'm working with.
Thank you very much. We have no more time because of the fact that we have to leave before 6. So thanks so much.
Thank you.